Hello everybody, so we're on the next chapter. That's either kind of exciting or like whoa. Anyway, let's take a look at page 64. On page 64, so now it's like module 2. Topic 2, actually it's module 1, topic 2. Yes, topic 2, still module 1, topic 2. Okay, so we're looking for patterns. In fact, if you'd done the warm-up on the page before, which you should have done, you can see that we're looking for patterns, right? So you can see plus 5 plus 55 plus 55 plus 11 plus 11. This one doesn't have a good pattern, but this one stays at 0. But so you're looking for patterns. So anyway, from there, let's keep looking at patterns. Okay, so if I look at this, it's called Pascal's triangle. Okay, so it says, all right, list at least 3 patterns you notice. Okay, so I don't know, you guys look at it. This pyramid thing right here. I mean, one of the things I notice is that first of all, I see that that all the ones, I see ones on, ones on the outside. I see that, all these ones, right? I see the, here's what I do see this 1, 2, 3. I see this diagonal 1, 2, 3. Let me show you. See this. It talks about the rows. Row 1. So I see on this diagonal, those are the rows. Row 1, row 2, row 3, row 4, row 5, row 6. So I see the row numbers. This is actually the 0 row up here. First row, second row, third row, fourth row, fifth row, sixth row. What else do I see? I don't know. It's actually kind of symmetrical too, isn't it? You know, I see the 1, 6, 15, 20, 15, 6, 1, 1, 5, 10, 10, 5, 1. So I see that, okay? So describe a pattern for the number of terms. Well, let's see. The first row, way up here, first row has just one thing in it. Second row has 2 numbers in it. 2 numbers, I'll go hashtag. Third row maybe has 3 numbers. Fourth row has 1, 2, 3, 4 numbers, and so forth and so on. Okay, 4 numbers, then 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7 numbers. Okay, so describe a pattern within each row. Within the rows, well, there's not much except for I do see symmetry. I see symmetry. See how that 20 is there, 15, 15, 6, 6. So I do see symmetry. I do see some symmetry. Okay. Then it asks for the sum. The sum in each row. Okay, so let's add them up. Let's go back here and add them up. It wants the sum. So if I add these up, that just adds up to 1. That adds up to 2. 1 plus 2 plus 1 is 4. That adds 4. 1 plus 3 plus 3 plus 1 is 8. 1 plus 4 plus 6 plus 4 plus 1, let's see, that's 16. I want to add those up. 1 plus 5 plus 10 plus 10 plus 5 plus 1, 32. Do you guys see a pattern? I bet that adds 64. What do you think? I bet that does. Get a calculator, but you can add that up to 64. I'm sure it does. So then this is what they add up. They add up to 1, 2, 4, 8, 16, 32, and 64. Okay, I definitely see a pattern. Okay, now, how do you determine the next row? This is Pascal's triangle. Okay, watch. That's how it goes. You're adding up the numbers. So, for instance, we'll go 1 plus 1 is 2. How do I make the 3? 1 plus 2 is 3. 2 plus 1 is 3. How do I make it? Okay, 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. Okay, how do I make the next one? 1 plus 4 is 5. I'm just adding the numbers. 4 plus 6 is 10. 6 plus 4 is 10. So all I'm doing is adding the numbers. So then, if I want to keep going, and I want to make the 7th row, I would do 1. 1 plus 6 is 7. 6 plus 15 is 21. 15 plus 20 is 35. 20 plus 15 is 35. 15 plus 6 is 21. 6 plus 1 is 7, and then a 1. 8th row, 1 plus 7 is 8. 7 plus 21 is 28. 21 plus 35 is a 56. 35 plus 35 is 70. 35 plus 21 is a 56 also. 21 plus 7 is also 28. 7 plus 1 is 8 and 1. Okay, there is my 7th and 8th row. That's my 1, 7, 21, 35, 35, 21, 7, 1, and then my 8th row is 1, 8, 28. Can you see this? Oh, you guys, I'm so bad. Here you go. Sorry about that. 56, 70, 56 again, 70, nope, 56, 28, 8, and 1. I'm just repeating these numbers. And I can keep building by adding up, getting the number, adding up, getting the number, adding up, getting the number. Okay, so that's Pascal's triangle. Okay, all right, so let's scoot the page to the other side. So a sequence is just a pattern involving an ordered arrangement. A lot of times it's just numbers, but it's a pattern, okay? So it can be either a figure or numbers or something, but the term. So for instance, this is the first figure, so that's our first term. This is our second term, our third term, and our fourth term. This is a sequence. Let's see what the pattern is. So the pattern seems to go from, it's dots, 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 but getting smaller, isn't it? So it's getting smaller. So what happens is each figure is 4 less dots, right, per figure, right? Or 1 on each outside axis, okay? So to draw the next figure, this has got 1, 2, 3, 1, 2, 3, 1, 2, 3. I'd go 1, 2, 1, 2, 1, 2, 1, 2. That's the 5th figure. The 6th figure, go 1, 1, 1, 1, 1, and the 7th or last figure just has to be dot, okay? Okay, so now numerically, let's add them all up, okay? I think if I add all these up, I think there's a total of, let's see, count them up. Got 1, 2, 3, 4, 5, 6. 6 and 6 is 24 plus 1 is 25. 1, 2, 3, 4, 5. 1, 2, 3, 5, and 5 is 24. Plus 1 more is got to be hold on, it's 21. I counted it wrong. 16, 16 plus, okay, is 17. 21. I'm not counting these right. 20 plus 1 is 21. 4 and 4 and 4 is 16 plus 1 is 17. 3 and 3 times 4 is 12 plus 1 is 13. Okay, there's my figure. I've got 25 dots, 21 dots. I've got 17 dots, 13 dots, okay? Now, so let's put this in a chart. We got term 1, that's my first term. It has 25 dots. Term 2, it has 21 dots. Term 3, it has 17 dots. Term 4, it has 13 dots. So term 5 has, well, let's see, 2, 2, 2, that's 8, makes 9 dots. 6 has 4, 5 dots, and 7 just has 1 dot, okay? All right, there's my pattern. Okay, great. Awesome, we did it as a chart, first term and its value, all the way down to the 7th term. Okay, turn the page. Okay, so on the next page, okay, Jessica's investigating her family tree by researching each generation or sets of parents. She learns all she can about the first 4 generations, which includes her 2 parents, her grandparents, her great-grandparents, and her great-grandmother. Okay, so think about the pattern. So we start with the 2 great-parents, and then they have a couple of kids. So we got other great-grandparents, that'd be 4. And then other great parents, that'd be 8 of them. Then other great parents, so it's like a tree. We start with 2, and they have 2 kids, and they have 2 kids, they have 2 kids, so it'd be like 16, 32, 64, okay? So it just keeps growing by a multiple of 2, doesn't it? So it says, okay, determine the number of parents of the 5th. So the 5th generation then, we keep going this pattern. So here's my 1st, 2nd, 3rd, 4th, 5th. So here's my 1st generation, 2nd, 3rd generation, 4th, 5th, and 6th. So we'd have 64 parents. If they all lived, we'd have that many parents, grandparents, whatever. We'd have in the 5th, we'd have 32 parents, grandparents, or whatever, right? All of them. In the 6th generation, if they all lived, they're all alive, they survived to the age of like 500 or whatever, we'd have 64 parents, grandparents, whatever, okay? So what's going on? It's a multiple of 2, isn't it? So just a multiple of 2, right? You see times by 2, because you keep doubling it, right? So let's put this into our chart, okay? So our first term is our 1st generation. There's 2 parents. Our 2nd generation is our this is like the great-great-great-grandparents, the great-great-grandparents, the great-grandparents, the grandparents, your parents, and then you, whatever. Okay, so then 2nd term, is 4. 3rd term is 8. 4th term is 16. The 5th term is 32. And the 6th term is 64. Okay, got it? All right, so we have our term number and we have our value. Okay, we could write it like this: 2, 4, 8, 16, 32, 64. So it looks like a sequence. Good. All right, how am I doing? Except you can't see what I've got, so forgive me. Here it is. And of course, you can pause the video anytime you'd like. So let's look at the next page. I'm going to do this page, and then I'll have you guys do the others on your own for homework. But let's analyze it. So we've got squares. 1, 2, 3, 4, 5, 6, 7. Looks like a 7 by 7 square. 1, 2, 3, 4, 5, 6. Maybe a 6 by 6 square. 5 by 5 square. And a 4 by 4 square, right? So it's really squares. Analyze the number of squares, small squares. So it's a squares. And they're getting smaller, right? So then the next one would be like a 3 by 3 square. Next one, so that'd be little, right? 3 by 3 squares would have to look like this to follow the pattern. And then a 2 by 2 squares would look like that. And a 1 by 1 square, which is just a little itty bitty box, okay? So here's my first term, my second term, my third term, or third box, fourth box. This would be my fifth box, my sixth box, and my seventh box, okay? So first box, second box, third, fourth, fifth, sixth. If we wrote these in some kind of numerical order, we'd have a 49, 36, 25, 16, 9, 4, and 1. And so those make up a sequence. It's my sequence. Right? Just a list of numbers in order. So let's put that into a table. My first term, second term, third term, fourth term, fifth term, sixth term, then seventh term. And the value of that term is how big the box. So my first term was 49 squares. My second term was 36 squares. My third term was 25 squares. My fourth term was 16 squares. My fifth term was 9 squares. My sixth term was 4 squares. And finally, my last term, my seventh term, was 1 square. Okay? right, so what I'd like you guys to do is continue this, okay? So same thing for page 68 and page 69, page 70 and 71, okay? You can do this, and I'll leave that to you, okay? All right, that's all I have. Stop. Stop recording.